Hi there, everyone. This is going to be a little bit different from the usual sort of tutorial style that I do. Today, I'm going to introduce you into a concept that I'm going to sort of talk about a bit more over the coming weeks and months, probably quite a bit in 2026. And I'm going to show you one specific network that I think does really, really cool stuff. The concept I want to talk about today is something called format bending, and I recently presented this work at Mutek in Japan alongside TouchDesigner.
And then you can basically apply any kind of image-based processing to that. And so we can use audio as that ramp to do sort of real-time sorting. I switch between things, and some of these oscillators might be loud. So, sorry. Oh, that's not too bad. So we can take the different properties of different kind of audio to process that sort in a different way.
Format bending is basically sort of a summation of experimentation that I've been doing over the last 10 years in some capacity, but maybe more formally over the last like 4 or 5. And what it really is, and let's cut to a little slide here, is it's this idea of working with information and data and not just focusing on that data in one specific form. So for example, you might have a audio file, and what would happen if you converted that to an image, edited as an image, and then converted back to an audio file? So you are allowed to do sort of different operations based on the container of the media. And something we're kind of quite used to in TouchDesigner is this idea of changing between different data and media types. So you might have an object, you can convert that into channel data, you can have it as a pop or a chop, and you can also have it as data. You can do a bunch of processing. So for example, here we could do a bunch of image processing, convert that back into channel data, back into the original image, and have something that's either the same or altered depending on how we're actually processing that. And for me, something that really inspired me, let's see if I can get to the next slide. Something that really inspired me in this process early on was a project I was involved in 2015 as part of a conference called Seeing Sound. And in this conference, there was an artist who was collaborating with a bunch of kind of participants at the conference to bounce radio waves off the moon. And these radio waves could include images. And the process of taking an image and converting it to a radio wave and bouncing it off the moon involved this intermediary step where there was an audio wave in between. And so this really got me thinking about how data and the transmission of data can really transform an image. So kind of material as process or process as material. And here we have the original and the returned image that's been reduced by that moon bounce technique. And honestly, I much prefer this image. I really like the texture and grain that's been added into it. The effect that I'm going to kind of talk to you today about is a very specific effect that works with turning data into sound, particularly a kind of a technique called a wavetable. And I've already done a video on wavetables. So this video here kind of contains all the information you need on learning about what a wavetable is. I talk about some of the theory in Max. I show how to bring that into TouchDesigner and build something. Let's just have a look or listen to what that sounds like. A couple of months ago, I made this effect in TouchDesigner that converts images into sound, and lots of people got in touch about this, and I decided to make a tutorial. The technique that I'm using is called a wavetable. You can see that already it's quite a rich sonic technique, and you can make even things like beats. You can do a lot of stuff with wavetables. I also have a video here which I won't play, but this is basically a slightly different method of turning data into sound in TouchDesigner. And finally, this one kind of evidences the more sort of complex things you can do with wavetables. So the most basic kind of thing you can do is just turn them into sound, but you can also use them as a means to transmit other kinds of information. So this is something I kind of experimented with, inspired by that moon bounce idea. I have used this technique to turn light into sound, make beats out of real-time images, and even turn images row by row into sound, which I can then transfer via audio or radio. This required a bit more coding, but it was still very fun. The technique we're going to dive into today is wavetables for sort of more creative use in terms of transmitting information. I'm going to ignore all these other examples and go to this one. Today, I'm going to cover this technique, and over the next few months, I'll be going back and looking more deeply at lots of other format bending techniques. So stay tuned for that. But basically what we have here, and I'm going to bring up my parent parameters so we can make some changes if we need. But basically what we have here is we have an image, and I'm cycling through that image. I'm just using an LFO. And we can see here that we're moving through it line by line. There's a few things here that we're kind of doing that just allow us to listen back to it. And I'll go into that in more detail later. And then we're turning that series of data back into an image. And we can see that basically we're not losing anything. We can recontextualize it or resample it here. So if I turn on this audio, it's a bit glitchy, I think, because I'm recording. But basically what's happening here is we're turning that image into data, that data's turned into sound, and then we're turning that back into an image. And something that I think is really interesting about these types of techniques is how they don't have to just go one way. So they can actually be performed in sort of both directions. So an example of this is I'm just going to flip this on to record. I'll just switch this to the R channel. And let's make sure that I actually have my audio device plugged in. So this is some of the extra stuff that's sort of going on here. Okay, we just want the regular microphone. Hello, 1, 2, 3. And what we can see, and I'll just reset that. So what we can see here is as I'm speaking, we're taking that data and filling up this kind of image buffer. And if I pause that and copy, important to lock it. And I'm going to actually just feed this back into my network as my audio input. So now when I actually move through that, we should be recycling that image. And let's see what that sounds like. We're taking that data and filling up this kind of image buffer. So what we can see here is as I'm speaking, we're taking that and then we can actually perform operations on the image. It's quite glitchy, but it allows us to actually make some interesting kind of operations here. And I'll show you a more high-res way we can work with this in a minute. Let's just turn that up. I find a crop works really well. So what we can see here is where data kind of what we can see here is so we can make lots and lots of kind of alterations to this audio. And while that's kind of just one kind of snippet of audio that I've grabbed, I found that actually if I take data and save it in a much higher format in like something like a TIFF or an EXR file, I'm able to actually output quite kind of high quality audio. And this is audio I could just send to you as an image, and you could plug it into TouchDesigner and play it back. So this is a little sample of an artist I like called Venetian Snares. Let's see if it works. you're removing data, it's important to sort of add in a bit more volume here to sort of kind of plays back. And you can also play this back at a different speed. You can resample this at different speeds. You can also use something like a sine wave. So you can use this technique to sort of create wholly new kind of audio-visual relationships and do sort of live audiovisual processing that kind of truly responds. So this is something that I think is super interesting as a technique. So what I'm going to do now is I'm going to close this up and we're going to build this from scratch so that you have something that takes an image, converts that into sound data, and then moves that back into image. So you can do processing in that in-between phase. We're going to start with a blank network. And the first thing that's nice to do is just grab an image to bring in. I'm going to use this one. And I'm going to use a fit to just scale that into a square for the time being, because that's going to make our lives a little bit easier. So 1,000 by 1,000, and I'll just say fit outside. And then what I want to do is I want to bring that into a top two. We could always add in a null in our chain, and let's do that for good measure, just so that we can make some subsequent changes in that image chain before bringing it out to this data. And what we have here is we have basically like a singular row of pixels. So let's just kind of look at the output that we have here. So we have, this is just kind of a visualizer. So we're going to use a top to chop. We're going to look at the RGB data. We're going to have a warning, and that's totally fine. We can look at the RGBA if we want, but basically that's just telling us there's extra channels that we're not using. The A channel is going to be not used anyway, so we can just remove that. And then that means we're not kind of adding extra data to our chain that we don't need to process. So here we have one line of pixels. And if we were doing this to actually take that image and recombine it into a full chain of data and then bring it back into that original image, what we would normally do is we'd go to crop, we'd look at full image, and we can see here that we're bringing that back into image here. But what we actually want to do is we want to look at this V start. And what we can see here is if I scan through this, we're basically moving line by line through that image from the bottom to the top. And one way to sort of visualize that would be, let's put that into a fit. Let's scale this value. We'll move this around later. So we want to translate this value here. And we also want to just minus 0.5 because we're moving from minus 0.5 to 0.5. So we can see here that we're moving this up and down. This is a bit of a janky way to do it, but that's okay. This is just to sort of give you the idea of what is happening. Just so we can kind of see that whole image emerge, I'm going to add in a feedback. I'm going to add in a over. I'm just going to pop this into a null, drag that there. And so now, if I move this, we'll see bits body, but we'll see that we're forming Willem Dafoe line by line. Just add in a keyboard in, just so we can reset that feedback. And so here we have our like basic visualization here. And we actually want to move through this data in a more sort of continuous way. And so I'm going to add in a ramp. I'm going to apply this to my UV start. And I want to turn down my frequency to 0.1. And now we can see it, we're getting a much better spread on that image. So we can think of this as sort of our visualization stage. And maybe we'll make some updates to this later to make it just run a bit more kind of streamlined. But this is basically how we're going to just make sure we're viewing that image and how we can see that we're scanning through this and everything is going to plan. If you really want to make this a bit sort of more in your face, I'm just going to add in a fit here, and we're going to do 1000, and we'll do 4 pixels high, and I'll just do fill. So then we have a bit of a chunkier kind of line of pixels going in there, so the image is a bit more fleshed out, but that's totally up to you. And so now we have this visualizer. I'm going to move this up here. What we can do is we can now see if we can translate this into audio. So let's bring this out into a audio device out, and let's see what happens. I'm going to turn my output to black hole 2 channel, just because that's what's feeding my sort of internal sound card, or actually, let's do Zoom audio device. And so we can see here that we have this data coming through, but it's not in a sort of a form that we can play back. It's not cyclic data. So what we could do in our top 2 is we could go to channel and switch extend left and right to cycle. And then also switch this sample rate to 44,100. So now actually playing back that data. But something that I actually have found is much more efficient for me is, let's just set that back to the default and hold and hold. So what I found is more efficient for me to make sure that the audio is really synced to that data is I'm going to use a resample, and I'm going to use an oscillator as the start end reference. And this is going to lock that into our kind of time frame for actually playing back audio in this audio realm. So let's plug that into the resample. Under my resample common tab, I'm going to turn time slice to off. And I'm going to go into, on my method, new rate, new interval, and set this to 44,100. The reason that we're setting this sample rate in both the instances I showed you to 44,100 is because that is the number of samples that we have in 1 second of audio. So we can think of this equivalent to sort of a second of audio that we're kind of pushing through at any one time. So let's see what that sounds like now. And I've just found that this method, locking it to that oscillator, just allows me to have a bit more robustness in sort of just making sure that that audio doesn't waver too much. But you can use either technique. Just have that very quietly because it's quite a loud, noisy sound. So we have this sort of one-to-one here. So we have our image, we're converting it to audio, we're converting that back into an image again. And we could put steps in between here where we can actually modify it. But if we want to take an input and convert that into an image, let's give that a go. We take in some audio. So let's do audio device in. I'm going to switch that to my microphone. I'm going to add in a math because I might need to boost this value, a null. And now let's turn that into a top. Okay, pretty quiet there. So let's ramp this up on our multiply. So let's see. Okay, there we go. And so you can kind of tweak this until it kind of hits a value that makes sense for you. And now we have this representation of our kind of input audio, whatever that might be. I'm going to go ahead and plug that into my fit. Maybe worthwhile kind of adding in a switch later. And one other thing, just because of how I'm sort of comping these together, this over would actually work better here as an add. So now let's kind of go in and see what is happening. Okay. Just going to turn that into an add as well. So now we can see that we keep adding to this audio. What I'm going to do here is I'm just going to reset that, and at the end of this, I'll copy that, and then we can play that back through. 1, 2, 3. Hello. La la la. Okay, perfect. Copy, disconnect. And now let's bring that back into our fit here. And now let's see what happens if we play back some sound from this. We can go ahead and just plug this back in as well. Set that, and at the end of this, I'll copy that, and then we can play that back through. 1, 2, 3. Hello. La la la. Set that, and at the end of this, I'll copy that. So you also comp these two things together. You get Willem Dafoe and Dan Tapper's voice kind of combine. So you're able to actually create these sort of like data moshy things. And actually, if you sent this image to someone, if you exported this and sent this to someone, it would actually kind of work out as something that they could kind of use. A couple more things that we're going to do just to make this nicer is I'm going to add in a switch here. And then we can switch between audio recording or the original image. So that's kind of useful. And something else I'm going to do is at the end of this LFO chain, what I want to do is I actually want to reset this feedback. So every time it hits the end of its kind of chain, I want to hit feedback to just reset so we don't have things overwriting on each other. So what I'm going to do is I'm going to create a logic. And I always get kind of confused by these things. And we're going to say on when greater than 0. And I'm just going to use a math to flip that value around. There's probably a better way of doing this. I'm going to drag that to my feedback. So now let's see if that resets every kind of loop. There we go. So at the end of each iteration, we're going to reset that feedback. Very, very cool. So there we have it, a method for processing images in really different and interesting ways. Let's also add in this Venetian snares track. Okay, what I'm going to do is I'm going to sort of put a slightly neatened version of this patch on my Patreon. You can download that for free and you can play around with that as well as building this from scratch to get an idea of how this technique sort of works. But yeah, this is the start of a bunch of what I think are quite interesting ways of sort of experimenting with data, transforming it into different realms, processing it there, and then kind of turning it back and seeing what happens. So we have had some interesting visuals here already, which is really cool. Thanks for watching.